This is MAT 221, Calculus 1 with Mrs. Johnson. I wanted to make a video showing how to use Mathematica tables to discover limits and the coding that we have in Blackboard. You'll notice when you're in Blackboard, in the Mathematica folder, this is week 3, that there are coding in here that I have put in there to help you with some of the coding in Mathematica. And I'm going to go here to coding to table for tables. And when you click on that, it will open up a Mathematica notebook that looks something like this. Now what's really cool about this is the code. This code comes from the Mathematica manual. And what's really nice about this is we can just use this code, so you won't have to type the code in yourself. It's an actual Mathematica notebook. First thing you want to do is get it into your current memory once you open it up, and you do that by doing evaluate and then evaluate the notebook, and then you'll see that Mathematica will put all this into its current memory. Now this is looking at the rational function x squared plus 5 minus 6 over x cubed minus x squared minus 2x. And what it's doing is it's forming limit tables as x approaches 1. If you notice, this is coming from the right side of 1, right? You can see these are values coming from the right side, and these are coming from the left side of 1. Now, why are we even looking at 1? If we look up here in Mathematica, and if I ask Mathematica to factor, which is a command in Mathematica, I'm going to say just factor the denominator. I'm just going to Control C and then Control V and then Shift Enter. You can see that it factors the denominator. It actually factors it into these factors of x minus 1, x, and x plus 2. Notice Mathematica does it in reverse order of what we usually would see there. We could also use the solve command. I'm going to open up the Classroom Assistant palette. And in the y equals x, I'm going to use the solve command here and say, where does this function q of x equals 0 for the variables of x? In other words, what are the zeros of this function, Mathematica? And you can see that there's the zeros of the function. I want to know not q of x, I wanted to know the denominator. Where is the denominator equal to 0? And the denominator is equal to 0 at these 3 places. We know from pre-calculus that when the denominator of a rational function is equal to 0, there's only 2 things that can happen. Either I will have a vertical asymptote at that point, or I will have a hole at that point, and the limit will exist. That I'll have this bullet hole in the function, and the function will still have a limit as we come to that point. So what these limit tables show us here is if we look at this function as x approaches 1, what this is doing is it's giving us the numerical evidence to show whether there's a limit or not. So as x is approaching the function at x equals 1 from the right side, you can see it here, you can see that the output of the function is approaching 2.3 repeating. And as I approach 1 from the left side, the function is also approaching 2.3 repeating. This is the numerical evidence in Mathematica showing us that the limit exists as x approaches 1, because the right-handed limit is equal to the left-handed limit and is approaching 2.333 or 2.3 repeating. Now, if we look at the other points here of this function, instead of looking at the right side of 1, let's look at the right side at -2 and Shift Enter. Notice it will change the table. Now as x is approaching -2 from the right, the value of the function is getting really, really large in the negative direction. Now let's do the left side at -2. Notice the output changes. And as x approaches -2 from the left side, the value of the function is getting really, really large in the positive direction. Here is our numerical evidence that there's a vertical asymptote at x equals -2. As we approach from the right-handed limit approaches -infinity. As we approach from the left-handed limit is equal to +infinity. Therefore, we say the limit does not exist, and there's a vertical asymptote there at x equals -2. Now, what about at x equals 0, which is our other time where the denominator is equal to 0? Let's find the left-handed limit and the right-handed limit at x equals 0. What do we notice here? This is telling us that as we approach 0 from the right side, the value of the function is approaching infinity. As we approach 0 from the left side, the value of the function is approaching -infinity. Again, this is giving us a vertical asymptote at x equals 0. Now, if I actually plotted this function, and you see that I did plot this function in Mathematica, you can see the evidence that we just talked about in those last tables, that as we approach -2, right, we have a vertical asymptote here, and as we approach 0, we have a vertical asymptote here. But as x approaches 1, the limit of the function exists. Now, we could also look at these other tables here, which is the tail end behavior of the function, and say, well, what's happening to this function as x goes to infinity or as x goes to -infinity? And you can see here from the tables, we have numerical evidence supporting that as x approaches infinity, the curve approaches 0. And as x approaches -infinity, remember this is scientific notation here, the value of the function also approaches 0. In other words, we have a horizontal asymptote as x approaches positive and negative infinity of y equals 0. Again, the graph supports that as we go toward positive and negative infinity, we have a horizontal asymptote here. So these coding for these tables that are done here for you is kind of convenient. And if you wanted to change to another function, you have to simply just go up here and change the function. Let me show you what I mean. Now, if I went into Lumen and we were looking at, this is Lumen, I think this is homework number 9 or 10. And I wanted to know these limits here as limits approach infinity, or if I wanted to know these limits here, we could actually use Mathematica to help us with these limits. Here's another one, having a limit. We could find all these things using Mathematica, right? So let's look at some of these ones here. I'm going to look at this one right here in Lumen. It is the square root of x squared plus 10x minus 2 minus x, and I want the limit as x approaches infinity. So I come into my Lumen, my coding for tables, and I typed this in here, which is the function I got from Lumen. I'm going to now just evaluate my notebook with this new function, and then I'm going to go down here where we look at as x approaches infinity, which is the right tail of the function. And it says, you can see it here, it's getting closer and closer to 5. Let's go into Lumen and see what the answer is here. And there's our answer. So you can see how you can use this to help you with your homework.